Okay, so for the ones who were following me, remember that that my slideshow was a little bit different last year. So what happened is I switched over to a completely different computer. I'm now basically running on a Ubuntu machine, and I transferred all my files, but for whatever reason, I forgot the slideshow I used for the previous episodes. But that's all right. I've got all the information here. So just to reiterate what where we are. So if you haven't seen the earlier ones, please use what is now popping up at the top right to navigate to the earlier videos. We are at 2.3, so we are right here at the, oops, that's actually not what I wanted to do, at the MVC and OOP section. That's what we're going to talk about, and as you can also see, it's the last conceptual topic before we actually then jump into the languages. So again, I will try to basically talk about this from a non-code perspective. A lot of things will make sense to you later. However, I've given this a lot of thought and basically have worked with a lot of people I onboarded with various levels of pre-knowledge. And so what I want you to do is basically simply accept that there will be things that will be kind of hard to grasp right now, but you will have a bigger aha effect later on when we actually like start putting things together. So what I always see is that people start out with the actual languages, and then they sit down with their Udemy courses or their free code camp or what, however they learn, and then when it comes to, okay, now you've got the tool set, now please apply it and generate an app or like follow your dreams and all of that, then what happens is that all of a sudden they don't really know how to apply it and what to make of it. And that is something I want to avoid. Also, like a lot of anti-patterns that normally arise is something that we really don't want to start. So in order to understand what we're doing when we're then jumping into code, I want you to just bear with me on that one. So what is MVC? That's Model View Controller. That is basically, a couple of principles. You can see I wrote that down as separation, reusability, maintainability, and overview. Now, separation, that's the most logical thing, is so apparently we're dividing something into a model, into a view, and into a controller. So our code is divided, and this can be meant literally as well. So those will be separate files. Reusability, that's a little bit something that we need to think about. So let's just say if we divide code up into segments, right, or files, or however you want to look at it, then that means that those parts can be reused individually rather than all together. So if you basically say like, okay, this is how a particular functionality looks like in the browser, then I can basically say like, well, but in a different app, or in a different circumstances in the same app, it looks differently but does the same. So we would basically then, for example, reuse a model and apply a different view. And again, you don't have to understand this at this point, but I mean, just to understand that you now have create the ability to reuse your code and don't have the problem that you have to repeat yourself. Maintainability. Now, every beginner I have ever seen will fall into this weird pit of an endless spaghetti code where files are hundreds of miles long, and it is really hard if you change something. Not only does it break everything, but it's really hard to basically work on the right piece. And you have to repeat a lot of the logical steps that you're doing on particular conditionals and so on. So we want to avoid that, and the separation into Model View Controller really helps us in doing so. And overview, that's a little bit, well, a summarization of that. So initially it seems weird that, like, okay, but if we divide something, it's harder to keep an overview. But in reality, there's something that we refer to as cognitive load. So if you look at, and you can compare this to regular text if you want to. So it makes a huge difference if you click on those little accept our terms, and you click on those terms, and all of a sudden 42 pages of insanity need to be read. But if you say, like, okay, but those are divided into like really, really logical sections, right? Kind of a humanized version of the terms and conditions, where you say, like, okay, this is what we guarantee, this is what we don't guarantee. Those are the rules that you need to adhere to. Then actually what you get is a little bit more structure and a little bit of more overview. And in actual code and in actual length, that means you're looking at a file that ideally has around like 50, 60 lines of code. And you can basically, the better you get, immediately grasp what that file is doing, rather than looking at something where you scroll and scroll, and then you get to a point where you notice you need to scroll up again and find, like, what does that variable mean, and so on. And it's extremely hard. The complexity of what your brain needs to do in order to understand what is happening is simply overwhelming. And MVC helps you to basically set the stage, at least, to avoid those problems, because ironically, this beginner issue of, well, I want to write everything as it happens, leads to exactly that as soon as complexity comes to a certain point, it's just like it's too much, and you lose control over your own project. So, that was a rant. So how does this look like? Again, we divide it up by model view controller. So we don't need to understand what this actually means, but at least I want you to give you an idea of what is a model, what is a controller, or what is a view. And so a model would basically handle data of all sorts. So data that we either pass, between different elements, or even make persistent, and so on. In most cases, your model will be the layer that would basically take care of a database, right? So that's like the persistent data. Okay, so you changed your name, we're going to save that on the database, and so on, and we're going to retrieve it from the database if somebody asks for it. So that's classically what a model does. But not necessarily, right? So handling data could be all kinds of maybe that's those are files that provide particular structures and who knows what. So don't understand this as a hard connection. It's just that most commonly that'll be basically how you can look at it as the layer that does the transaction to a database. The view is actually relatively simple. You can also basically imagine, okay, this is your template. So your forms, if you want. So if is classically HTML, but I mean nowadays or even back in the days, I mean, can be all kinds of formats. But in a more classical sense, it'll basically be your HTML, and those are little templates that you want, so that you use to put together your page, and they have placeholders. So in most cases, you will use something like like a templating logic or templating engine, and so you can fill those templates with the information that normally you get from the model, but we'll talk about that later. So there's very little logic in here. There's something in coding that we refer to as business logic. Business logic is something that does not apply to a view, and you will have different opinions here. Now, some people say models handle business logic rather than controllers. That's a longer discussion that you can have depending on what language, what framework, and so on you're using. But I'm very opinionated when it comes to the view. So modern template engines enable you to do a lot of things, and you can declare variables, and you can do all kinds of stuff. But I actually am going to make a hard point here, and I mean, I'm pretty sure that nobody can change my mind on that after over 10 years in the industry. So with the exception of iterations and conditions, so basically repeating elements and having if clauses if you want, so right. So basically saying, well, I show this depending on something or not. With the exception of that kind of logic, no logic needs to be in the view, absolutely none. And that's actually rather important. So whenever you find yourself wanting to apply that, then it's probably supposed to be in the controller. So in the controller, I basically just put this ball with logic on there because it's really not easy to describe what a controller does without looking into actual code. But if you want so, the controller is the instance that is most self-explanatory, right? Because it controls. So it controls the model and the view. So I'm visiting a particular page. Let's say something like Facebook. And so I come to facebook.com, and everybody goes to facebook.com. However, for me, it looks different than for you, doesn't it? So why is that? Well, so a controller would decide that, okay, so what I'm going to show me is different than what it will show you. And, based on who you are, what kind of information you need and so on. So it grabs the relevant data, in that case from the model, or models. It's of course more complex, but let's imagine it to be simple. From the model, and places it in the templates it can use, to generate your wall and the ads and all of that kind of stuff, and the pictures and you name it. So it grabs it from the views and basically places those in the renders those to the browser so you can basically see it. And that's it. I mean, that's as simple as it gets. This is what people refer to when they say model view controller. Now, again, how that looks in code and in files and in structure and so on, in architecture, that depends. But that is basically something you should adhere to, regardless of what you're using, that you basically have a clear separation. Now, the only exception to that would basically be, and I'm not even sure if I like that, but in the JavaScript frame, if in the front-end world, web components are normally so contained that even though they have a separation, so you would see, okay, there's a view and there's a controller, and the controller talks to the model and so on. At least the view and the controller happen in the same file, so they're just separated basically by section, paragraph, however you want to look at that, and that works if it's really small enough as a concept, right? So there's something called single responsibility, which basically means that like a web component or actually anything should only be there for a particular to fulfill a particular task and nothing more. Another typical beginner problem is that like too much is done in one component of whatever sort. So if that unit is small enough, then that's all right. But for every other instance, I recommend that MVC also means different files for you. Oh, excuse me. Okay, so far for model view controller. So what about OOP? OOP is object-oriented programming. So in this case, I have like three different columns. So here is my YOOP, and this is basically procedural, which basically would be the opposite of object-oriented programming. Procedural means I'm going to start here, that you basically go top to bottom. So at the end, in one single, what's called a thread, code runs, from top to bottom, even though a code can call, left and right, different files here and there and so on. At the end, logic basically runs one after another. And in such a scenario, what you would have is that as a beginner, you tend to do this automatically, that you say like, okay, I'm going to start, at a certain point and just going to run through it. And that makes things very repetitive. You will notice that as soon complexity gets a little bit high. They're the same readability issues we already mentioned when you're not using MVP. It's a maintenance nightmare and a bug creep. So what I mean by that is you change something and the whole thing doesn't work anymore. It's really hard to test. I mean, unfortunately, I don't think we will ever get into actual testing with testing frameworks and so on, but maybe we will. It's very hard to basically generate anything that has a higher complexity with that kind of style. So what we have nowadays, and in theory also a different principle than OOP, is and I'm sorry I don't mention that anywhere here, is functional programming, which would basically be something that is almost like, how should I say, like little static micro systems that are very, very strict in what they do, and they can basically be talked to and they adhere to I mean, most importantly, to the single responsibility principle again, which is like they do little things and you just chain them together in your actual production code to have the outcome that you want. So a lot of those principles we can apply to OOP, but in theory that would basically be the third method of generating your code on a principle basis. But let's get back to OOP for now. So OOP, why, right? So we're now in the left column. Why? Well, for abstraction, inheritance, and encapsulation. So those are weird terms if you're new to the whole thing. So what abstraction means is that in order to reuse something, I need to abstract the actual use case out of it to a point where it can be reapplied to a similar but not the same situation. So what do I mean by that? So let's say you have a keyboard, and the way you want your program to understand a keyboard is that it has certain properties, right? So let's say keystrokes, okay? You send a particular code on a particular key down event, and you are reacting on that accordingly. However, what you actually want to do is you want to account for a US layout, a keywordly keyboard. And all of a sudden, you find yourself having the necessity to also account for Japanese keyboards. So, and they're different, the keys are somewhere else and so on. So all of a sudden, you find yourself having differences. So rather than repeating, the complete logic, what you do is you create keyboard as a form of layer that would have all the properties that every keyboard in the world would have. So the general functionality, what exactly I can do with it, that it understands combinations of keys, like if I'm using control and stuff like that. So those kind of things I can abstract up, and then on a lower level, I can basically say, okay, so I am now extending a keyboard to generate something new, and that will be a US keyboard. And a US keyboard has certain properties that only a US keyboard has. And a Japanese keyboard also uses the general keyboard, but then applies properties that only the Japanese keyboard has. And that's basically what abstraction means, if you can follow. And that also already explained the inheritance. So in both of those cases, what we did right now is to basically say, okay, so the US keyboard inherits the properties of a general keyboard. So I don't have to define all of that again. I can basically just say like, okay, now I'm just going to add onto it to like what makes a US keyboard unique towards a keyboard in general, and the same of course for the Japanese version. And if we think about like encapsulation, that's something that automatically comes with it in that case. So when I now change properties of whatever level I'm on, so let's just say eventually, I don't know if it was Lenovo, but somebody came out with a keyboard that can also do fingerprints. And so that is something that now, in theory, a US keyboard and a Japanese keyboard can do. So I'm basically now going to change the actual keyboard class, so not the US class and not the Japanese keyboard class, but the actual keyboard class can add that functionality or change whatever I need to change in order to facilitate the fingerprinting mechanism. And now automatically both my US keyboard and my Japanese keyboard have that ability. And that is something that makes a lot of sense when your application grows. Which is, by the way, something I know this is probably also relatively new. So in either case, what you normally do when you create applications, they just grow in complexity. And by the way, the more successful they are, the more they grow in complexity. If you were to look at the Amazon webpage, in the early days, it was a fraction of what it is today. So the complexity of any kind of application you're building, and by the way, regardless of whether or not that's software or web or native apps or whatever it is always going to grow in complexity. So the fundamentals you lay out in order to have a nice structure, a good architecture, in order to allow for that to happen without eventually having to say I have to throw everything away and start from scratch, has an importance I really cannot emphasize enough. So let's look at this from the last step and give you some homework basically. So I want you to imagine that you have something like that. We talked about this as keyboards. So let's just say we have a class car, right? So what a class is, again, you don't have to understand, but basically you can initiate a car now, right? So create a new car from wherever that comes from. I mean, let's let it be magic. You have a magic wand that creates cars, and those cars have particular properties. So how many wheels does it have? And what properties does every car have, right? Is it correct to say every car has 4 wheels? And then you might say, well, in general, maybe yes. But is it correct to say every car has 5 doors? And you would probably say, no, that already depends more. But the more you think about it, the more you will notice, well, not every car has 4 wheels. I mean, there are different little tweaks a car can potentially have. And then the next question would be, okay, what if I manipulate the car? So for example, if I say like, okay, I mean, a car is quite useful. It has a lot of properties I use, but what I actually want to build is a motorcycle. So can I just, get a new car and then, like delete two of the tires and then see how manipulate the whatever I get from the car magic wand until I have the motorcycle. And the answer, of course, is, well, that even if that worked, that's very risky, because as soon as like what a new car gets worked on, that might completely ruin my motorcycle. So at that point, the question is, well, will I also have a new motorcycle? And at which point you will think, well, but there are some properties a motorcycle and a car have in common when it comes to, like, well, it has a motor and that requires gasoline and, all that kind of stuff. So at that point, you want to say, well, maybe I haven't abstracted high enough. And that's probably true. So what you actually want to do is, no, I need something like a new vehicle. And then a vehicle has, for example, a car, and a car inherits certain properties that every vehicle has, just as a motorcycle would inherit properties as every vehicle has. And you can have multiple levels of those. And why am I confusing you with that? Is, well, because there was actually something that a former manager of mine introduced me to, and it was a very simple question. Is like, well, can you please write down how to make a peanut butter and jelly sandwich, and what kind of steps are necessary in order to achieve that. And the whole gist of this game was to basically notice that, well, as soon as you can always basically refer to, well, but you need to do this first, and so on. There's always detail you're missing when you describe in how certain processes work, and how you would abstract and reuse them is basically something I want you to think about. So you can do this in a shower or whatever, but since we are going to jump into code the next time, it would make sense for you to actually take, like pen and paper and write it down, and maybe spar with somebody else and say, hey, can you describe to me how you would make a peanut butter and jelly sandwich? And you will notice that person will actually mention something that you haven't thought about. And if you then read it back or add that to your list and, like play that game a little bit, you will basically start a way of thinking that will make you a better programmer. So I know you can go insane with that. So like understand that to actually write down how a peanut butter and jelly sandwich works is you can write books about that. So don't go crazy, but just go to the point where you basically start to trigger in your brain what you need to account for in order to achieve something. And that's it for today. It's a short and spicy episode, but again, let me basically explain that one more time. The reason why we're doing this is because I need you to basically be introduced to certain thinking patterns prior to us jumping into code. And I really hope that helps you progressing faster. So we will basically catch up time that because others are nervous. It's like, well, show me your first line of code, and now I'm going to learn, this, and now I'm going to learn that. And then they're going to go to some kind of 6-week boot camp, and they have like 8 languages that they got introduced to, and none of them they can actually use. So that's what I want to avoid. And that is why I think this approach makes sense, and I hope that like once we are working with code, you will basically be able to remember this and say, okay, I understand now. It makes so much more sense. That's it. Also, a little shout out to India. I wasn't in front of YouTube for a while, and have basically then recently looked at my followers and noticed that I have a very high percentage of males between 18 and 25 from India watching my videos. So hope you guys are doing well. You are, besides the US, the majority of my viewers, which I know isn't that much, but I find that very interesting, and also very telling, because if I'm looking at tutorials, I normally find Indian content or English content, but from Indians. And one of the reasons I gotta admit that I'm starting this was that what was taught or what is taught in many of those tutorials is not only outdated, but sometimes actually dangerous when it comes to security. And I am therefore a little bit skeptical about low-level development that basically isn't really controlled from any instance. Don't forget we have a profession that isn't protected in any way. Everybody can run around and call themselves a web developer, and that makes things very, very difficult. Now, needless to say, I know brilliant Indian programmers. Some of them, work for the biggest companies in the world, and they're geniuses in their trade. But don't forget, those are not the ones you book for $5 with Fiverr. So that's why I'm actually pretty happy and almost proud to maybe help setting at least the fundamentals to get a little bit of a better groundwork out there. So we have a next generation of young Indian developers that provide higher standards, and that would be great. And that is basically it for today. Sorry for that little diversion at the end. So I'll see you, and we're going to start with, let me actually see. I think we're going to start with HTML. Let's jump to that quickly. Yes, so next week we're going to do HTML. That is relatively boring as a start. It's a markup. As you can see, there's languages in markup. The reason for that is that HTML is a markup language. That's what the ML, by the way, stands for. And it doesn't do anything if you want, so it's a document, right? So we need to be very familiar with it nonetheless, because it is the basis of how a browser interprets a page in general. And we going to look into how everything works in that respect, and hopefully we'll get through that relatively fast, but nonetheless there are little tweaks here and there and so on, so it's nothing you can learn in 20 minutes either, unfortunately. Anyway, thank you so much for listening. See you next week, and you have a wonderful day.